You're listening to the Bare Metal Cyber Prepcast, created to help you succeed in your educational journey. Learn more at baremetalcyber.com, where additional prepcasts, books, and training materials await. Let's get started. The purpose of the shared responsibility model is to make explicit the division of security duties between cloud providers and customers. Unlike traditional IT, where one organization owns and manages everything from hardware to applications, cloud introduces a layered environment where some responsibilities shift to the provider. This model is foundational to CCSP study and to professional practice. It clarifies who owns what, reducing gaps and assumptions that often lead to incidents. Without it, organizations may believe providers cover more than they do, leaving critical controls unmanaged. For exam preparation, understanding the shared responsibility model provides a mental framework for scoping questions correctly. In practice, it anchors governance, contracts, and operational planning, ensuring that accountability is mapped and enforced across the entire stack. At its core, the shared responsibility model delineates control ownership between the provider and the consumer. Providers ensure that infrastructure is secure, resilient, and operated under strong physical and logical protections. Consumers remain accountable for how they use those services' configurations, identities, and data protection. The division is not arbitrary but formalized by the service model, IaaS, PaaS, or SaaS. These boundaries are not negotiable in daily operations, but must be understood and embedded in governance and training. For CCSP candidates, questions often hinge on recognizing where the line falls, particularly when service models shift duties subtly. Patterns of responsibility vary across service models. In infrastructure as a service, customers manage operating systems, middleware, applications, and data, while providers manage the hardware and virtualization. In platform as a service, providers take on more managing operating systems and runtime while customers focus on applications and data. In software as a service, the provider manages nearly everything except the customer's data and access. These patterns illustrate a sliding scale. As abstraction increases, provider responsibility rises, but consumer accountability for data and identity remains. On the exam, recognizing these distinctions ensures correct mapping of responsibilities in scenario-based items. Provider responsibilities include physical security, managing data center facilities, ensuring availability of hardware, and securing core infrastructure like networking and virtualization layers. They also manage the resilience and patching of managed services they fully control, such as SaaS applications or platform runtimes. These responsibilities are largely invisible to the consumer, but are validated through certifications and attestations. For professionals, provider responsibilities emphasize trust, but also the need for verification. For exam purposes, they remind you that certain layers are always outside customer scope. Customer responsibilities center on identity, access management, data protection, and configuration of services. Even in SaaS, where infrastructure and applications are managed, customers must enforce least privilege, classify and protect data, and configure security options correctly. In IaaS and PaaS, responsibilities extend to operating systems, applications, and middleware. This distinction explains why misconfiguration is such a frequent cause of incidents. The technology may be secure, but customer choices expose weaknesses. On the exam, consumer responsibility scenarios often test whether you identify configuration, logging, and data as remaining under customer control. In IaaS environments, the operating system and middleware are the customer's responsibility. This includes patching, hardening, and securing services. Providers ensure the host and virtualization, but the consumer must ensure the guest is maintained. On the exam, items about IaaS often test whether you understand that patching obligations extend to operating systems and databases managed by the consumer. This is a critical distinction between IaaS and PaaS, where those tasks shift to the provider. Application layer responsibilities remain with the customer in both PaaS and SaaS. In PaaS, customers build and deploy applications which must be coded securely, tested, and monitored. In SaaS, while the provider delivers the application, customers still govern how they configure it, how data is handled, and how users are granted access. This principle reinforces that the customer cannot outsource accountability for how business processes use the software. On the exam, questions often present SaaS misconfiguration as a consumer responsibility, testing whether you recognize that provider coverage does not extend to how the application is used. Network security boundaries define who manages segmentation, firewalling, and traffic filtering. In IaaS, customers configure firewalls, virtual private cloud settings, and routing. In PaaS, providers control the platform, but consumers may still manage application-level filtering. In SaaS, customers may rely on built-in controls but remain responsible for access restrictions. These boundaries illustrate the layered nature of responsibility. For the CCSP exam, network boundaries often appear in scenario questions requiring you to decide whether provider or customer is accountable for segmentation or monitoring. Logging and monitoring obligations also follow the model. Providers may supply logs from the control plane and service events, but customers must consume, analyze, and act on them. Customers also enable logging features where optional, ensuring visibility into their use of cloud services. This reinforces the principle that while providers deliver tools, consumers must operationalize them. In exam scenarios, logging often appears as a shared area. Providers ensure logs exist, but customers are responsible for reviewing and responding to them. Encryption responsibilities include ownership of keys, key management, and rotation. Providers may offer encryption services, but customers often decide whether to use provider-managed keys, bring their own, or hold them externally. Key lifecycle policies remain under customer control. This distinction matters in compliance scenarios, where regulators may demand evidence of consumer-managed key control. For the CCSP, encryption questions often test whether you can identify the customer's role in choosing and managing keys, regardless of who provides the underlying cryptography. Patch management also illustrates division of labor. Providers patch their infrastructure hypervisors, hosts, and managed services, while customers patch what they control, such as operating systems, containers, or custom applications. In serverless or SaaS, patching shifts almost entirely to the provider, but code-level responsibilities remain with the customer. For CCSP learners, patching is a frequent exam theme because it clarifies the line between managed and customer-controlled assets. Compliance attestation responsibilities reflect this same logic. Providers maintain certifications such as ISO or SOC to demonstrate their controls. Customers must provide evidence for their in-scope responsibilities, such as data governance or application security. Together, these create the assurance chain for regulators and stakeholders. On the exam, compliance scenarios often test whether you understand this split. Provider certifications reduce burden, but do not eliminate customer obligations. Penetration testing policies require adherence to provider rules. Customers may test their own assets hosted in cloud, but testing provider infrastructure is restricted. Providers publish rules and approval processes to protect shared environments. For exam preparation, understanding that penetration testing is not unrestricted but governed by provider policies ensures correct responses. Data lifecycle responsibilities, including classification, retention, and secure deletion, remain under customer governance. Providers may supply tools, but the consumer decides how to categorize, how long to retain, and when to delete data. This reinforces the theme: providers deliver services, customers govern use. Exam items that highlight lifecycle questions often expect you to recognize customer accountability. Backup and recovery responsibilities are similarly divided. Providers may guarantee infrastructure resilience, but customers must decide what to back up, how often, and how to validate restores. Business requirements drive frequency and scope, but execution depends on consumer choices. This makes backup and recovery one of the most important ongoing customer responsibilities and a common exam scenario. Finally, misconfiguration risk illustrates the practical importance of the model. Studies show misconfigured cloud services are among the leading causes of breaches. This is not a failure of provider security but of consumer governance. Understanding the model makes clear why customers are responsible for configurations. On the exam, misconfiguration scenarios test whether you recognize that responsibility always falls to the consumer. For more cyber-related content and books, please check out cyberauthor.me. Also, there are other prepcasts on cybersecurity and more at baremetalcyber.com. Multi-account and organizational models are strategies for partitioning ownership across workloads. Instead of placing everything into a single account, organizations distribute environments into separate accounts for production, development, or sensitive workloads. This reduces the blast radius. If one account is compromised, the scope of damage is contained. Organizational units and account hierarchies also make it easier to apply policies consistently while granting autonomy where appropriate. For exam purposes, multi-account structures demonstrate risk reduction through segmentation, echoing the broader theme that clear boundaries enhance resilience. Delegated administration and least privilege principles extend governance across these accounts and roles. Delegation allows administrators to manage subsets of resources without granting universal access. Least privilege enforces that administrators receive only the permissions they require. This separation of duties prevents concentration of power and reduces insider threat risk. In the CCSP context, exam questions often hinge on whether you recognize that governance structures should enforce distributed, role-based responsibilities rather than centralizing them in a single authority. Encryption control models illustrate another layer of responsibility. Bring Your Own Key, or BYOK, allows customers to import encryption keys into the provider's environment, maintaining ownership of generation and rotation. Hold Your Own Key, or HYOK, extends this further by keeping keys entirely outside the provider's infrastructure, requiring external validation for access. These models provide increasing levels of assurance and compliance alignment. On the exam, BYOK and HYOK scenarios test whether you can distinguish consumer obligations for key lifecycle management from provider-delivered encryption services. Managed database and messaging services illustrate how responsibility shifts with managed platforms. Providers handle infrastructure operations, patching, scaling, replication, but customers remain accountable for data protection, access policies, and query governance. This balance underscores that managed services reduce operational burden but do not eliminate consumer accountability. For the exam, these scenarios remind you that even with high-level abstractions, customer obligations persist around configuration and use. Serverless computing and function as a service, or FaaS, push this abstraction further. Providers operate infrastructure, manage scaling, and patch runtimes. Consumers supply code, define policies, and protect data. Missteps in code quality, access management, or logging remain consumer risks. Exam items referencing serverless test whether you recognize that, while operational responsibilities shrink, governance and data accountability remain with the customer. Container orchestration platforms, such as Kubernetes, illustrate shared complexity. Providers may manage nodes or offer control plane services, but consumers must configure clusters, enforce network policies, and secure application workloads. The division varies by service tier but always retains customer accountability for workload-level protections. This layer division often appears on exams as scenario questions about where security gaps may emerge. Marketplace and third-party services extend the shared model. While providers host these services, consumers remain responsible for due diligence, secure configuration, and ongoing monitoring. Simply deploying a third-party solution does not transfer accountability. On the exam, these scenarios often test whether you can distinguish between what the provider guarantees and what the consumer must validate. Monitoring boundaries illustrate the importance of visibility across layers. Providers expose control plane events, such as changes to configurations or identities, but customers must consume and act on this data. Data plane logs record access and resource activity, while application telemetry captures behavior within workloads. Together, they form comprehensive visibility. For CCSP learners, questions about monitoring test whether you can identify what data is available and how responsibility is divided for acting upon it. Incident response coordination reflects another area of shared responsibility. Providers may manage infrastructure incidents, but consumers must handle their own workloads. Evidence requests, response timelines, and communication channels must be clearly defined in advance. This ensures that investigations and remediations proceed without confusion. For exam purposes, incident response scenarios emphasize the importance of planning with providers to ensure effective collaboration. Breach notification processes combine regulatory and contractual obligations. Providers may notify consumers if incidents affect infrastructure, while consumers are obligated to notify regulators and customers if their data is compromised. Timing and scope vary by law and contract, making clarity essential. On the exam, breach notification scenarios highlight the interplay between provider communication and consumer legal obligations. Cross-border data transfer responsibilities emphasize compliance. Consumers must ensure that transfers align with privacy regulations and contractual safeguards, such as standard contractual clauses. Providers may offer compliant infrastructure, but consumers remain accountable for lawful processing. Exam questions may highlight this by testing whether you recognize that compliance obligations cannot be outsourced entirely to providers. Contracts codify responsibilities. Service-level agreements, or SLAs, define uptime and performance commitments. Data processing agreements, or DPAs, define data handling obligations. Audit rights ensure consumers can validate provider claims. Together, these instruments turn shared responsibility from abstract principle into enforceable practice. For the CCSP, contract-related scenarios often test whether you can connect governance obligations with legal instruments. Risk transfer mechanisms complement these contracts. Cyber insurance, indemnification clauses, and liability caps distribute financial consequences of incidents. While they do not replace security, they reduce exposure. On the exam, risk transfer questions often appear in governance contexts, reminding you that accountability has both technical and financial dimensions. Responsibility matrices and operational runbooks translate high-level assignments into daily tasks. Matrices document who is responsible for what, while runbooks describe how to perform those tasks. This operationalization is the only way to ensure shared responsibility becomes practice rather than theory. Exam relevance lies in recognizing that mapping and documentation are as important as controls themselves. In summary, the shared responsibility model reduces ambiguity by clarifying provider and consumer obligations. By mapping ownership across infrastructure, platforms, and applications, organizations ensure that controls are implemented, monitored, and validated without gaps. Misconfiguration and misunderstanding remain leading risks, but structured governance, contracts, and runbooks close those gaps. For the CCSP, this model is a cornerstone. It anchors how you scope, prioritize, and validate cloud controls. In practice, it enables secure, confident use of cloud services, turning shared trust into structured assurance. Thanks for tuning in to the Bare Metal Cyber Prepcast, your trusted source for cybersecurity news and insights. Remember to subscribe at baremetalcyber.com so you never miss an update. And visit cyberauthor.me for best-selling cybersecurity books that equip you with expert knowledge. Until next time, stay secure and stay vigilant.